Welcome. In this presentation, we will explore the concept of fail-safe actions in control valves, specifically the difference between fail-open and fail-close valve configurations. Understanding how these valves behave during system failures is critical to maintaining safety and process reliability. A valve's fail-safe action refers to what the valve does automatically when it loses its air supply or control signal. In other words, if something goes wrong, like power failure or a signal loss, the valve moves to a safe position by itself. That safe position depends on the process, and in some systems, it means keeping the flow running is safest, and in others, completely stopping the flow prevents accidents or damage. Valves operate using two basic air action types, air to open and air to close. In an air to open valve, air pressure is required to open it. When air is lost, the valve naturally closes. In an air-to-close valve, air pressure is required to close it, meaning it stays open even if the air fails. Choosing the wrong fail-safe direction can be disastrous, which will lead to fires, equipment damage, product loss, or unplanned shutdowns. And that's why understanding fail direction is essential for plant safety. A fail open valve is normally open. That means no air signal is present, and the spring mechanism keeps it open. A fail open valve uses an air to close design, which means air pressure must overcome the spring to push the valve closed. If air supply fails, the spring automatically returns the valve to the open position, ensuring that flow continues even during signal loss. A fail-closed valve works the opposite way. It's a normally closed valve, and the spring keeps it shut when there is no air. It operates on an air-to-open principle, meaning air pressure must be applied to open it and allow flow. If the air supply is lost, the spring forces the valve shut, cutting off the flow immediately to prevent possible hazards. Now, when designing or troubleshooting a system, it's vital to consider the safety consequences of each valve's fail position. Never assume how a valve will respond. Always verify and double-check the process and instrumentation diagram or P&ID. Determine what the safest valve position is for your process, and make sure your instrumentation is configured in the event of a failure so that the valve automatically moves to that safe position. This consistent approach protects equipment, personnel, and the process itself. Now, if this video helped you understand valve fail open and fail close concept, give it a thumbs up. And don't forget to subscribe for more automation tutorials. Thank you for watching and see you in the next video.